purpose steam turbine. API standard 611. So remember that the standard number for general purpose steam turbine, because this can be a potential exam question itself. This model, we shall learn about the inspection aspects of API 611 general purpose steam turbines for petroleum industries. This picture shows, as you can see, the sizes is not that big, it's small. So you have an inlet, you have an outlet, and there is a mounting plate here, and steam turbine is placed on top of that. And it can be in vertical position, it can be in horizontal position. So he used to drive the equipment that is usually used as a spare and small in size or power, or in non-critical service. So it's a small size. General purpose steam turbine are used when steam pressure less than 700, temperature less than 750 degree Fahrenheit, or speed is less than 6,000 RPM. You can note that the turbines, they've got a higher speed than the compressor. That's the main reason they are termed differently. Pumps. Please note that the special purpose turbines, larger power or size, and used in critical services covered in 612. So special purpose in turbines which are larger in power and size, and using critical services 612 and 611, which is the present lesson, is about the general purpose, which is smaller in size and power. And special purpose is larger size in power, 612. We go through some definitions and some pictures here, so just refresh your mind. Anchor bolts attach the mounting plate to the support structure. It can be, the support structure can be a steel or concrete. Called anchor bolt here with nuts and washer. Critical speed is when rotor is in a state of resonance or excessive vibration and chatter. It's a speed at which the natural frequency of assembled rotor is reached at the operating speed. So that's a natural frequency, it's a resonance, and that's called critical speed, and it causes vibration. Operating range shall be well away from these critical speeds, either higher or lower. Hold down bolts, mounting bolts, bolts that screw the turbine to the mounting plate. Hydrodynamic bearing, low clearance assembly that relies on the film of oil. So as the turbine starts rotating, the oil is fed through this, and it makes like 5-10 micron of distance, so to avoid the friction. As you can see here, there's a housing. The whole thing is housing, called housing, and then the actual bearing material is inside. And once it starts rotating, as you can see here, there's a thin oil going through these lines. These lines are very tiny. The depth is very shallow, and it pushes it up, so there is no friction on the bearing, and that's called hydrodynamic bearing. Maximum continuous speed 105% of highest operating speed, and this is a typical mounting plate, close view, that the turbine is bolted and aligned on this. Observe point is like a witness point in an inspection test plan. So on general projects, we call it witness point, but here API say observe point and witness point, which observe point, as far as we know, is like if the client's representative inspector would not attend or does not attend it, the vendor still goes ahead and do the job, perform that activity. So on a witness point, also the client receives same as observed point a notification for inspection. But if the client's inspector does not attend, then they have to put the job on hold. So that's called witness point. Observe point, they don't need to put it on hold. They can go ahead even if the client's inspector representation does not attend. Oil means lubrication bearing housing that's lubricated by the thin film of oil by compressed air, that's hydrodynamic bearing. Shall means mandatory. Should is recommended, not mandatory, but it is advisory actually. Total indicator reading. So one full reading, you put dial indicator here, and if it's completely balanced and it's not elliptical in shape, or it doesn't, it's completely balanced, so you see it's 0. And if the degree of balance is more, then it starts moving up and down, because this would not be exactly circular here. So one total a complete revolution of monitor surface. So if it is, say, you can get a direct dial reading from this dial indicator. You can see here that in this location is starts 0, and then at the highest one, so the highest would be at the point where it shows the highest reading here. It's like 0.02 inch. So it could be either way. Also, you would see the same reading. Trip speed at which the turbine shut down by an independent emergency overspeed device. There is always a trip speed on the turbines, not to damage things. If the pressure or temperature or goes up more than a limit, then the trip speed is triggered and the turbines shut down automatically. Witness, as we talk about this, if there is a notification of inspection and the client's inspector or representative does not attend, they cannot carry out that test, and they have to wait and reschedule or whatever. And normally they charge the client for delay when they could do that. So it's very important when annotating the ITP. Absolutely critical item activity should be witnessed, and non-critical should be observed. So responsibility, that means the ultimate responsibility for coordinating documentation, delivery, technical aspect of the equipment, auxiliary system, and everything practically lies with the vendor or supplier or manufacturer, or whoever you want to call it. In case of conflict between the standard and the inquiry shall govern. So although this is a standard, but if there is any conflict, the inquiry shall govern. But once that inquiry or bid has been placed to turn into purchase order, then the purchase order shall govern. So that always purchase order take precedence. There is a conflict between the requirements of the standard and the purchase order or the project spec. Basic design. General purpose steam turbine, including auxiliaries covered by this standard, shall be designed and constructed for minimum service life of 20 years and at least 3 years of uninterrupted operation. So if it's made according to 611, general purpose steam turbine, you should have a minimum service life of 20 years and 3 years of uninterrupted operation without the need to maintenance or shutdown. When there assumes full unit responsibility or full responsibility for all the parts and auxiliaries, including the turbine, all equipment's normal operating conditions shall be specified on the data sheet. It is obvious. All equipment shall be designed to permit rapid and economic maintenance. This is again sort of obvious. There is a table that shows design criteria and specification for cooling water systems for the turbine. And sound pressure level is normally measured in decibel. It's a distance of 1 meter away from the pump, and although it's not mentioned here, but most of the specs and standard, they say 85 decibel maximum. So that means that's based on human threshold of tolerating 85 decibel of sound for 8 hours working continuous. So that's why 85 decibel. Fasteners should at least be at least a quarter inch or 6 millimeter larger than the diameter of the bolt head. That's for tolerance. This is normal. Pressure casing shall comply with ASME Section 8, Division 1 or 2. So depending how onerous it is, you could go for Division 2, but normally it's Division 1. And the pressure casing, the pressure test is also follows the ASME Section 8. Materials, casting factors, and quality of any welding should be equal to those required by ASME Section 8, Division 1. And manufacturing data report for third-party inspection and stamping are specified in ASME code that are not required since pumps excluded. So remember that although the pressure casing and the material and casting factor and all these elements, welding should be according to ASME Section 8, but ASME Section 8 is excluded, exclude the pumps. So they're only stationary pressure vessel that they see. But then the casing does follow that. That's what is the standard says. Each axially split casing shall be sufficiently rigid to allow removal and replacement of its upper half without disturbing rotor to casing. So normally it's a split half, as you see in the picture. Maybe I'll go back and show you the picture. As you can see in this picture, it's a split half. So there is a lower case. You take off the bolt, loosen the bolt, take off the upper half, do the maintenance, put the back the upper part of the casing, bolt it up. Okay, let's go back to our lesson. So as you can see here, the casting quality factor, if you do a visual or an MT or a PT, the casting quality factor is 0.8. If you do a spot radiography, it's 0.9. Or do an ultrasonic, same. And if you do a full radiography, it's 1. The reason is that, as we said in previous model, your degree of certainty of that casting is defect-free depends on the coverage and of NDE. So in case of full radiography, it is 100% sure that there is no defect, so the casting factor increases to 1. And this is equivalent to joint efficiency in welded joints, which is say from 0.7 to 10, depending on percentage of radiography and coverage. And type of radiography, say for full RT, again, it's only welds. And this directly reduces the thickness because your degree of certainty increased, so your safety factor can decrease. And the thickness can reduce in this case of the casting. Joint efficiency directly multiplied pro rata to the thickness. Mounting surfaces shall be machined to a finish of 6 micrometer or better. Depth of drilled holes shall be at least 1.5 times the stud diameter. So the drill depth should be at least 1.5 times. So at least you have one full engagement of one thread. So this is a minimum, 1.5 times the stud diameter. It is a diameter of the stud or the bolt. It's like a bolt without a head, actually. So this should be 1.5 times of this diameter minimum. Butt weld connection and a small 1.5 inch and smaller shall be reinforced by using forged welding insert or gussets. So this is a forged, so gussets or inserts, yeah, as you see, for stability. There's a table 2 that shows the surface finish for flat and raised surface that can be used. All of purchaser connection to the pump shall be accessible for disassembly without requiring any major part of the machine to be removed. This is for ease of maintenance. Rotors shall be capable of operating without damage at momentary speed up to 110% of trip speed. The 10% is for any surges and all, just to account for that. Shafts shall be machined with one-piece heat-treated steel. Shafts with diameter over 8 inch shall be forged. This could be potential exam question. First, this shaft should be one piece, because it is two piece due to constant moving of the part and the fatigue involved. So you should not if it is welded or it's two piece or so you might have a stress raiser here, and eventually you have a fatigue which fails much faster than it's one piece. And shafts with over a diameter 18 shall be forged. So forged is one of the best methods for manufacturing and widely used. The impellers and shafts are normally forged. Bearing, so here you can see a pump with measurements, the vibration, and there should be a limit on vibration, and there is a dial indicators here, before and after, both vertical and horizontal, to see that the movement of the pump while working is within limit, horizontal direction. Measurements. The material of construction shall be clearly stated in vendor's proposal. Weldable grades of a steel forging shall be repaired by welding using a qualified welding procedure based on the requirements of the ASME Section 8 Division 1 and ASME Section 9. All major weld repairs before hydro test. The complete forging shall be given a post-weld heat treatment to ensure stress relief. So if you have a major weld repair, post-weld heat treated to stress relieve it. And then the purchaser shall be notified before making a major repair. Purchaser shall specify the minimum design metal temperature, and concurrent pressure used to establish impactors and other material requirements. So that lies with the purchaser to tell the vendor what's the minimum design metal temperature and the pressure, so they can see that whether impactors is required or not. Vendor shall exercise caution in selection of material intended for services between -30 degrees and centigrade, or 20 degrees Fahrenheit and 40 degrees centigrade, or 100 degrees Fahrenheit. This is for brittle fracture. Nameplate shall be securely attached at a readily visible location on the equipment. Attachment piece shall be of the same material to avoid any galvanic corrosion, such as stainless or nickel copper. Welding is not permitted to do the welding on that because due to vibration it might fall off, so they normally pin it. Following data as a minimum shall be clearly established on the nameplate in units consistent with the data sheet. There's name, serial number, size, type, rated power, speed, first critical speed, second critical speed. That is a critical speed. That's normally the performance ranges between first and second critical speed. As we said, it should be away from that. Maximum continuous speed, minimum allowable speed. So there is no cavitation, because if you can't run on a certain RPM lower than that. So over speed trip setting, there is a trip setting also on the turbine, as we said, to avoid any damage. If the RPM goes too high or the pressure or temperature, then it trips, so it's shut down. Normal maximum inlet steam temperature and pressure, and exhaust steam pressure, and finally purchaser's equipment item number. Anchor bolts are in the purchaser scope unless specified in the PO. So normally the purchaser, because he installed it himself, so he buys the anchor bolts. Lifting lugs attached to the equipment shall be designed using maximum allowable stress for 1/3. So shouldn't be allowable stress of the lifting lug more than 1/3 of the minimum yield strength of the material. Remember, in actual material is 2/3, like casing and all that, but here it's 1/3 because there might be some movement, jerks when you're lifting it, so more safety, 1/3 of minimum yield strength. Instrumentation controls shall be designed and manufactured for use in the area classification. They call it IP group, or should, for example, there is H2S service, there is when There is a danger of fire or explosion, so they should be intrinsically safe. The instrumentation, and there is a, depending on the class and group, zone, let's say zone 1, zone 2, it should be designed according to that. Primary function of the governing system shall be to maintain the turbine speed at a set value by regulating the steam flow through the turbine. So there is a governor that regulates the flow, so that turbine speed is maintained. It shall not allow the turbine speed to exceed the trip setting by 2%. So if the setting is so if it's by more than 2%, the turbine keeps tripping there. Table 4 shows speed governors class versus maximum steady rate speed regulation, maximum speed rise, and trip speed, which is between 110 to 115%. Instruments and control panels. So when you say not more than 2% of the trip speed, because then you got two safety measures here. One is that once the trip speed is reached, so it trips shut down. If it doesn't shut down and trip speed system fails also, and it goes up, then the governor should be the second line of defense to regulate this, so it doesn't go over 2% anyway. So it should blow off. The instruments and control panel shall be completely assembled, piped and wired, requiring only connection to the purchaser external piping and wiring circuits. So this is obvious. It should be like a modular unit. You should just click and go. Gauges marked with the operating range. Operating range may be indicated on the tag next to the gate. There's a table 5 shows the minimum requirement for piping system components. So normally once you install it, you work your way from the first flange on bars and then do the piping. So the reference should be the pump itself, regarding leveling and elevation and protrusion and all this when connecting the piping to the pump at the site. Inspection, testing, preparation for shipment. Purchaser should specify the extent of participation in the inspection and testing by annotating his intervention points within the ITP, noting inspection requirements in the data sheet, etc. The purchaser and supplier would agree on the amount of advance notification, witness point, and inspection points. Prior to the purchaser witnesses the mechanical running or performance test, supplier shall confirm successful completion of the preliminary test. So they normally do a test just to make sure that everything is in order. Then they will invite the client or the purchaser to come and witness the mechanical running or performance test. The vendor shall supply the following data: MTR, manufacturer test record, examination and test records, any post-well heat treatment, any QC test and inspection report, any repair records, as-built and running clearances. Pressure-containing parts shall not be painted until the hydro test, leak test, ND examination, and inspection is complete. Because if they are done, coated before this hydro test or leak test, then the paint might mask the leak. So it's always after hydro leak test or any ND examination. And you cannot do most of the NDs like routine when the coating is on, or MT or PT, for example. Mill test report is the only required for the plates. It's not required for inventory items. So plates, it's always required, as in section 8 comes from there. And also as in section 2, they always say that mill test report is required for the plates or for pressure retaining parts. Casting surfaces shall be examined visually by vendor as per MSS 55. All forgings and bar stocks for major rotating elements shall be 100% ultrasonically inspected after rough machining. So normally you do a lamination check and before the machining, and after the machining you do another check. So you do a preliminary check, but then 100% it should be UT checked after rough machining. Why we do after rough machining? Because it's quite difficult to do UT check before rough machining, so that's why. Supplier should submit the mechanical running test procedure to the purchaser 6 weeks. It's always 6 weeks. API standard 6 weeks prior to test for review and approval. And normally it says here for steam turbine, remember centrifugal it was 5 working days, it's 10 working days prior to mechanical running test. For others actually it's 5 working, but for mechanical running test so they should give 10 working days notice to witness, because this is an important thing. And normally if you got 5 steam turbine, just one of them is done with a mechanical running test at the purchaser expense, because it's an expensive test. This should be a full simulation of the steam turbine at site. Pressure containing parts, hydro tested 1.5 times, maximum allowable working pressure for a minimum of 30 minutes. If the operating temperature is different from hydro test temperature, the hydro test pressure shall be multiplied by the ratio of material strength at the time of hydro test divided by the strength of the material at the time of pump operation. We have talked about this. So it's called lowest stress ratio. If the pump say is being operated at 500 degree Fahrenheit and the strength of the material at 500 is less than ambient temperature, and you're doing the hydro test at ambient temperature, then you have to multiply whatever the allowable stress is by lowest stress ratio. That means the stress at 500 at ambient temperature divided by strength as allowable stress 500 degrees centigrade. So because the stress maximum allowable stress 500 is less than that ambient, then you would have a 1 point something ratio, and that prorata would be added to the hydro test to simulate the hydro test pressure at actual working temperature. During mechanical running test, contract seals and glands should be used. If this is not possible, then the contract seals and bearing shall be leak tested at least equal to maximum allowable working pressure prior to final assembly. So during hydro test, you don't use the mechanical seal and glands because they might be damaged. They are not normally designed for the pressure hydro test. They are designed for maximum allowable working pressure, which is normally 1.5 times less than the hydro test. So, but during the mechanical running test, the glands and seals should be used because we need to see whether they can perform. Then also they don't leak. So at the same time at mechanical running test, we are also checking the leaking and they're tight proof. But API has provided the option that for any reason, if that cannot be tested, the seals. So there is some slave seals used during mechanical running test. For example, there is some slave seals used, and then there is the actual seal or the spare seal, both of them. The spare seals also, a couple of them normally supplied for, in case there is a leak during operation later on, so they can use it quickly there, increase the reliability and reduce the shutdown of the pump during operation. So these all should be tested to maximum allowable working pressure. Please note that it's not to hydro test pressure, it's maximum allowable working pressure for testing of seals and glands. Prior to hydro test and mechanical running test, all joints connection checked for tightness, any leaks corrected. During no-load operation for extended period of time during the test, the inlet steam condition may need to be reduced to prevent overheating of the unit and exceeding design clearances. So this is like a car engine, you're sort of running it, and while stationary. So there is no load on it. It's not running. So after some time, it might heat it up. If you go full throttle, it might heat it up because you're not running. You're not driving it. And so that's the same analogy here. The speed shall be increased to 110% of maximum continuous speed, just below the trip speed, and the equipment shall run for a minimum of 15 minutes at the increased speed. Then the speed, this is for mechanical running test, then the speed shall be reduced to maximum continuous speed at the equipment and then run for 1 hour. Hydrodynamic bearings shall be removed, inspected, and reassembled after mechanical running test is completed. And equipment prepared for shipment. Should be suitable, the packages for 6 months of outdoor storage. So remember, all pumps, compressor, turbines, packaging 6 months outdoor storage from the time of shipment. Flange opening shall be provided with a metal closure at least 5 mm thick with elastomer gaskets and at least 4 full diameter bolts. And threaded opening shall be provided with steel caps or rounded head steel plugs. And in no case shall non-metallic caps or plugs be used. This might be a potential exam question. So it should be steel plugs, not non-metallic, because they might be damaged the face. Lifting points shall be clearly identified, and also on the box that for shipment also should be identified, as well as on the pump. Vendor data during tender, vendor shall complete and forward to VDDR form to client. Vendor shall notify purchaser of any deviation. Drawings on the VDDR, such as GA general element drawing, cross-sectional drawing, schematics shall be included in the proposal. Vendor shall also note the list of components and materials used for each one. Bill of material. Vendor shall provide the guaranteed performance curves for power, flow, and speed. Contract data. Document deliverables shall be as per VDDR agreed between vendor and purchaser. Vendor shall submit progress report to the purchaser periodically as agreed, and vendor shall include installation, operation, maintenance, and technical data manuals with the turbine at the time of shipment. There are several annexes here. Annex A shows typical general purpose steam turbine data sheet. Normally, the purchaser would fill in the required output, flow, power, head, and the vendor would fill the rest. Purchaser also provides fluid composition and inspection requirements. Data sheet should be approved by the purchaser. Annex B explains dynamics, information on rotor dynamic analysis. You do not need to study this annex for example, because this is purely engineering. Annex C shows typical vendor drawing and data requirement. The actual package could use this typical VDDR and tailor make it to the project specific requirement, including any additional tests, material upgrade, etc. Annex D, lubrication system schematics for information only, no exam question. Annex E, normative, mandatory, shows typical procedure for determining residual imbalance. Look at the worksheet. Just to familiarize yourself. Annex F is informative, shows typical inspector's checklist. This checklist comes handy for ticking boxes while inspecting the steam turbine. Please familiarize yourself with the checklist, anything inspection related, and there might be potential exam question, not that you understand what this checklist is about. Annex G, informative, explains steam turbine nomenclature. Thank you for listening. See you at the next module.